friends, welcome to Science Studies YouTube channel. In the first video of electric current, in the part 1, we have learnt about how metals are categorized by the observation of drude and Lorentz. By the observation of the characteristics of the metals, we can classify the metals as a conductors which pass electricity and insulators which does not pass electricity according to observation of drude and Lorentz. In this module, I am going to teach you some other observations of scientists drude and Lorentz. They observed the condition of electrons, means charges, in a conductor. They observe in two situations. They observe the conductor in two situations. The first situation is conductor in open circuit, conductor in open circuit. And another situation is conductor closed in circuit, means connected to the battery. So the scientists drude and Lorentz observed the behavior of the electrons, the behavior of the charges in the conductor in two situations. In the first situation, they observed how charges are behaves when the conductor is open in circuit. Open in circuit means the conductor not connected to any battery. It is not connected to any battery. In the second situation, they observed the behavior of the charges, means electrons, present in the conductor when it is connected to the battery, means closed in circuit. So let's discuss about the first situation. In the first situation, so in the conductor there are two types of the charges: positive charges and negative charges. Positive charges and negative charges. How that positive charges behaves in the conductor? Actually, the positive charges in a conductor, the positive charges in any conductor fixed in their specific place. The positive charges plus ions, the positive charges present in any conductor, they are fixed in a particular position without having any movement. There is no motion to them. So these fixed charges are called lattice or lattice ions. Lattice or lattice ions. Lattice or lattice ions. This space is called lattice space. So where that positive charge is located between this space is called lattice space. In this space, negative charges means electrons, positive charges means protons. I have to remember, negative charges means electrons. So these negative charges are moves in the conductor in a random way. Some charges means some electrons moves up, some electrons moves down, some electrons moves from left side to right. I would like to compare the situation of flow of electrons in the conductor when it is open in circuit, means not connected to the battery, like the classroom without teacher. If you take your classroom an example, if there is no teacher, in the absence of the teacher, backbench students come forward, front bench students go back, they change their places, they jump from one bench to another bench, they create very nonsense in the classroom. Means there is no uniform way, there is no discipline because of the absence of the teacher. There is a random situation in the classroom. Like that, when the conductor is open in circuit, electrons present in the circuit, they move in a random direction. There is no proper direction. There is no uniform direction. So the electrons is random in motion. Random in motion. Random in motion. So due to this random motion, means some electrons moving left to right, right to left, up to down, down to up. There is no uniform direction. Due to this random motion, the electricity becomes zero. So the current I, actually current is denoted with I. So the current I becomes zero when the conductor is open in circuit. Why? Because even there is a movement of the electrons, even there is a movement of the charges, that charge movement, that electrons movement is not in uniform way. That's why the total energy, the total current produced in the open circuit of the conductor is becomes zero. So why I am calling the current at here is zero? Because actually current means the flow of electrons is called current. The flow of charges means electrons in conductor is called current. But at here the flow of electricity not takes place. The electrons moves in a random way. That's why the electricity not produced at here. This is the about first situation, the observation of Drude and Lorentz. They observed another behavior of the electrons in the conductor when the conductor is connected to the battery. Look at here, the behavior of the electrons in the closed circuit means when the conductor connected to the battery. When the conductor is connected to the battery, all the electrons which are moving in a random way, they are rearranged in a specific direction. They are arranged, the all electrons which are moving in a random way came to in a particular direction and travels in a single direction, means uniform direction, uniform motion. Look at here, when the conductor is open in circuit, there is a random motion. But when the conductor is open in circuit means when it is connected to the battery, the all electrons travels in a uniform direction. Travels in a uniform direction. Flow of electrons is called current. So when the conductor is connected to the battery, all electrons are flows in a specific direction. What is the reason? Why the electrons are flowing in a specific direction when it is connected to the battery? So I would like to compare this situation with your classroom. So while you are making that noise, while you are changing places from back to front to back, if any strict teacher enter into your classroom, what is the situation? Just imagine. Yes, everyone become silent. And each and everyone settle in their respective places. They maintain discipline, means they becomes into uniform way. Like that, when the battery is connected to the conductor, the all electrons, means students present in the conductor, means classroom, they becomes into discipline, means all electrons are travels in a uniform motion and uniform direction. Why these all electrons are moves in a uniform direction? Because the battery produce some force. That force is called electric force or electric field. It produces some electrical field. So this electric field or electrical force, nothing but the strict teacher who entered the undisciplined classroom. So due to this electric field, electric force, that electrons or start flow in a right way. I hope you understand about the observation of Drude and Lorentz. In the first video, we have discussed about the first observation of the Drude and Lorentz to classify metals as conductors and insulators. Are you clear? Then second observation, the flow of electrons in the open circuit and the flow of electrons in the closed circuit. From these two observations, we can answer why the bulb glows in first situation, not glows in the second situation and third situation, as we discussed in the first part of electric current lesson. If you not watch that video, I am suggesting you to watch the video for better understanding of the concept. Okay, please watch previous video also. Let's come to the point. Look at here. Why bulb glows in the first situation? Look at here. All the components are perfect at here. Bulb is good in condition. Battery also there. Copper wires also there. Switch also there. These all components are connected in a proper way, and also all the components are good at here. That's why the flow of electricity takes place. The flow of electrons means current. The current flows through the circuit, then it makes the bulb glows. That's why in the first situation, in the first activity, the bulb glows. What about second and third? As we discussed, in the second and third, the bulb not glows. What is the reason behind it? Look at here. At here, all components are there. No bulb is there. Copper wire also there. Switch also there. What is absent at here? Battery. There is no battery. Why? If there is no battery is not present means bulb not glows? Yes, because the battery produce some electric force. When electric force is produced in the conductors, the flow of electrons takes place in a specific direction, then current is produced, bulb will be glow. But as we discussed in the before, when there is no battery, all electrons in the conductor moves in a random way, then the total current electricity becomes zero in the circuit. Same happens at here. Due to the absence of the battery, electrons present in the wire means conductor not flows in a specific direction. Circuit is not completed, then there is no flow of electrons. Due to the absence of the flow of electrons, electricity is not produced. That's why the bulb not glows in the second situation. What about the third situation? In the third situation, instead of copper wire, we use nylon wire. Say so, no? What is the first situation? We used copper wire. But in the third situation, instead of copper wire, we use nylon wire. So nylon wire is an insulator. It is not a insulator. It is not a conductor. So it is not conduct electricity. It is not allows to the flow of electrons. Due to that, the bulb not glows. These are the reasons why the bulbs not glows in the second and third situation. I hope you understand. Are you clear? Next, come to the interesting point that is completely related to our chapter. That is definition of current. What is current? So they will ask question. What is current? Current can be defined as number of the charges that flows through a conductor in a time is called current. So current can be defined as the number of charges. The number of charges means electrons flows through a conductor. Flows through a conductor in time t. In time t is called current. It is very simple definition. Look at here. Current, the number of the charges. So NQ. So number of the charges means NQ. Q charges. The number of the charges. Charge is denoted with a Q. So charge is denoted with a Q. So number of the charges that flows through a conductor. That flows through a conductor in time t. In time t is called current. It is very easy to actually current denoted with I. So current means I. So I equal to, what is the current? Charges. Charges means Q. Pass through the conductor in a given time is called current. So the current can be defined as number of the charges that flows through a conductor in a time t is called current. The SI unit of the current, the SI units of current is, the SI unit of the current is amperes. The SI unit of the current is amperes, and SI units of charges means Q is coulombs, and SI units of time t equal to seconds. So from these values you can write the current formula. Look at here, SI units of the current, I, ampere. So ampere means 1 ampere equal to, you can write Q. Q means coulombs. Coulombs by time means seconds. Seconds. So we can write it is in the simpler form. So ampere can be denoted with A. So ampere can be denoted with A. So instead of ampere, we can write 1 ampere equal to coulombs C by seconds S. These are the SI units of the current. So 1 ampere equal to 1 coulomb by 1 second. 1 coulomb by 1 second is called current. So conduct can be defined as the number of the charges flows through the given time. This flow of current measured with a instrument. We know already, to measure the BP there is a BP mission means sigma manometer. Like that, to measure how much current is passed through a circuit, there is a instrument, there is a mission. That mission is ammeter. What is that? Ammeter. They will ask question for half mark. What is the instrument used to measure current? So to measure current we use ammeter, and it is connected in the series way, not in a parallel way. If you take any circuit, this ammeter connected in the series way. This is about the definition and formula of current.